Welcome back to my YouTube channel. Hope you're all doing great. Today we're gonna do our third transformation, that is rotation transformation. This is just an extension of our previous two lessons that were based on Cartesian plane coordinates. So what is rotation transformation? Rotation transformation is when we rotate a point about a fixed point at a certain degree. And there's some basic rules that we need to keep in mind before applying rotation transformation. So let's say P is the point and X and Y are the two coordinates, and we have to rotate this point about an origin at 90-degree counterclockwise. Let's say P is the point somewhere here with coordinates X and Y, and this is 0 degree, this is 90, this is 180, and this is 270, and this is 360, and this is the first quadrant, this is second, this is third, and the last is fourth quadrant. And we have to apply the rotation transformation. Means we have to rotate this point about an origin at 90-degree counterclockwise. That means, so the point will be here. So the rule is Pxy, and after applying the rotation transformation, so the new point P dash will be, we're gonna switch the coordinates and put a minus sign in front of Y. So our second case is if we rotate a point 180-degree counterclockwise. Let's say the point is here in the first quadrant Pxy, and if we rotate a point 180-degree counterclockwise, so the point will be in the third quadrant, and the new coordinates will be minus X minus Y. So the basic rule is after applying rotation transformation, the points will be minus X and minus Y. So our third case is if we rotate a point 270-degree counterclockwise. So that means if we rotate a point 270-degree counterclockwise, the new point will be in the fourth quadrant, and the coordinates will be Y minus X. So that means the new coordinates will be Y minus X. So these are the three rules that we need to keep in mind before applying rotation transformation. So our first problem is we are given these coordinates A, B and C, and we got to rotate these coordinates 90-degree counterclockwise about an origin. So first of all, we're gonna mark these coordinates here on the graph. So 2, 3, so 2 and 3, so that means the A point is here. and B 1 4, so 1 and 4, the B is here, and C 3 5, so 3 and 5. So now we're gonna join these points and make a figure. So A, B and C. So what we're gonna do, we're gonna rotate this figure 90-degree counterclockwise about an origin. So that means the figure will be in the second quadrant after applying 90-degree counterclockwise rotation. So first of all, we can apply this rule 90-degree counterclockwise. So A is 2 3, so the new coordinates will be -3 2 as per the rule, and B is 1 4 and C is 3 5. So the new B coordinate will be -4 1 and C dash will be -5 3. So now we're gonna mark these points here on the graph. So -3 2, so that means -3 and 2 here. So and the B coordinate is -4 and 1, so -4 and 1, so here. And the C dash coordinate is so the C dash point is -5 and 3, -5 and 3, so that means here -5 and 3. So now we're gonna join these points. So this is our solution after applying 90-degree counterclockwise rotation about an origin. So our second problem is rotate point P25 about C14 90-degree counterclockwise. This example is very much different than the previous one because in the previous example we have done a rotation about an origin. But in this example we're gonna do rotation about a point other than origin. So there are some basic steps that we need to keep in mind before solving these kind of problems. So as this is our new center of rotation other than origin, like C, so that means this is gonna be our virtual origin. So the first step is we're gonna subtract this center of rotation from point P25. So that means P25 minus C14. So our new point will be 2 minus 1 1, 5 minus 4 1. So A point will be 1 1. So that means here this is our A point. So after that we can apply rotation rules, which is 90-degree counterclockwise. So P dash will be minus yx. So that means So A dash will be minus 1, 1. By rule minus yx. So our third step is we're going to add center of rotation to this point, minus 1, minus 1. So add center of rotation. So after adding the center of rotation, let's say the point B will be like minus 1 plus 1, so 0, and 1 plus 4, 5. So this is our solution point. B05. Now we're gonna mark this point and also this point here on the graph. So A dash is minus 1 and 1, and our solution point B05 is here, 0 and 5. So this is our final point after applying 90-degree counterclockwise rotation about this center of rotation point C14. So our last problem is we're gonna rotate point P 1 minus 4 about C03 180-degree counterclockwise. So that means C is our center of rotation, or we can say that this is our virtual origin. So our first step is we're going to subtract center of rotation from this point, like 1 minus 4 minus C03. So our new point A will be 1 minus 0, 1, minus 4, minus 3, minus 7. So after that, we can apply rotation rules. Apply rotation rules. So 180-degree counterclockwise. So that means after applying 180-degree counterclockwise, so our A dash will be minus x minus y. So that means minus 1 and plus 7. So our third step is we're gonna add back the center of rotation to this point. Plus C03. So our solution point will be minus 1, 10. So this is our solution point. Now we're gonna mark this point here on the graph. So minus 1, 10. Minus 1 is x coordinate and 10 is the y coordinate. So minus 1, minus 2. So minus 1, 10. So here. So B minus 1, 10. So this is our center of rotation, and this is our final point, and this is our original point. So that means after applying 180 degree counterclockwise with respect to center of rotation C03. This is our solution point.